So this is week 7. This is the second part of our introduction to React. After last week, we took a first look into the world of React, a ton of new syntax. You're probably feeling rather overwhelmed at the moment because we really did introduce quite a lot of new stuff in one lecture, and it hasn't been the first time in this course. So really congratulations for sticking with it at this point. I promise it will be worth it as long as you can finally get some of these skills under your belt and actually practice with real projects. I think that's super important. In this lecture, we're going to do a few different things building on our React knowledge. This should be quite similar to the work that we did in the intermediate JavaScript lecture, in that we can pretty much do anything that we want with React at the moment. We could make pretty much any application using React, but it'd just be kind of tough. It would get quite messy at some point. We'd be repeating ourselves quite a lot. And we'd have to come up with a few really hacky implementations to get things to work. So first off, I'm going to be talking about a few sort of design principles, design patterns in React that come up all the time. We'll be talking about routing in React, which allow us to separate different pages into different screens that we can search for with the address bar, basically. We're going to talk about hooks, which make state components easier, essentially. Then we're going to be talking about material UI, which is this sort of pre-styled components library in the same way that Bootstrap is for just regular HTML and CSS. And then finally, I'm going to be talking about application level state. And I'll be introducing the React Context API for managing application level state. So first thing I want to talk about today is a few different of these design patterns, which hopefully make a little bit more sense when I dive into them. These shouldn't be too tricky. It should be just one slide each. So first off, I want to talk about the keyword this. We've mentioned this a couple of times already in previous lectures. The word this in JavaScript will always mean something different depending on the context where we use it in. So this came up when we were talking about class-based components. We were talking about classes, sorry, in 2 lectures ago. This referring to an individual cookie that the cookie cutter has created, sort of referencing itself. The problem is in JavaScript, this is constantly shifting. So an example here, we could be using this.sum method, which we're defining in our component class. Here, yeah. We can be using this.sum method in an on-click listener for our button. And we'd expect, okay, when we click the button, this is referring to this method because we're defining it inside of this class. And this always refers to this instance of the class. The problem is that this on-click is going to evaluate to a function. And when we use the word this inside of a function, this refers to the current function that we're running. So sometimes we'll get some errors when we try to use this like this. And the simple fix, sort of common fix that we've used for a long time is to use this bind syntax. So essentially, we can bind a function, we can bind a method to a particular thing. And here we're essentially just saying, okay, I want to bind this method to the current version of this, which is the current class. And if we do this, then inside of this sun method, this will still work as we're expecting it to. So that's totally okay. But this is a little bit sort of difficult to remember to do this every time. So a nice workaround is that we can use an arrow function whenever we have an on-click event or an on-change event or any one of these events that get called from React components. Because the nice thing about arrow functions, one of the nice things with arrow functions is that it totally gets rid of this behavior for functions. So normally with an anonymous function, with a function that we're declaring as a value, yeah, we have this keyword that pops up. But if you're using an arrow function, then this doesn't happen anymore. So we can save the extra line of having to bind this to a particular instance of this. It's also just quite difficult to remember to do this. So just remember, anytime that we're using an on-click event, an on-change event, if we get this sort of an error, we can just wrap this method in an arrow function. And then if we're calling that method inside the arrow function, we're just saying, okay, every time we click the button, then we're calling this method here. So that just hopefully saves a little bit of headache and a little bit of effort if that becomes a problem. Okay, next I want to talk about something called controlled components. We say a component is controlled when all of its values comes from either state or props, rather than user input. So there's a single source of truth for a component, which is the props that we're passing in. So the simplest example here is when we have an input, so a text field, for example. We want to log into Facebook, so we're typing our name into the username field, let's say. Usually, these input text fields track some state for themselves. So if I type the word Adam into my username, that input is sort of tracking what I've typed in already. And it does that using the value attribute. So there's a workaround that looks something like this, where this value is always going to come from a value that we're setting on the state of the component. And just anytime that that input gets changed, so every time a key gets pressed, essentially, we're using this on-change prop here to set the state of this component state to change that value to the new value. So if this sounds quite complex, there's a short video in this week's homework that explains this really well. It's a really nice concept in React, just to make it easier to reason with these components. You don't need to sort of wrestle with this one input that wants to carry a certain state, and then we have to sort of rectify that with this component level state that we're dealing with. And doing something like this for a form also makes it easier to submit that form. So since we already have a state object with everything that the form could contain, it's really easy then to maybe have like an on-submit handler or an on-click handler to a submit button, and then do whatever we need to do with that data. Okay, last thing I want to talk about quickly in terms of a design pattern that makes our lives a little easier with React is something called a fragment. So we mentioned last lecture already that we're not allowed to have two components next to each other like this. We always have to have some component that wraps all of the components inside of components, just like a simple rule of React. React just uses to render our components. It turns out that we get something from the React library called a fragment. So if we don't want to mess with the styling of any of our elements, even if we use something like a div comes with slightly different styling to having absolutely nothing around it. So the display property by default for a div, I think, is a block. So if we don't want to mess with the styling by wrapping something in a div, we can also use react.fragment. And there's this really nice shorthand that we can use instead of react.fragment, where it's just an open and close plus sign basically, just like this. So nothing inside of the JSX. This is a fragment because there's no styling, there's nothing. It's just an easy way to get around this rule that we're not allowed to put two components next to each other inside of a component. Okay, so next thing I want to talk about is routing in React. So I'll dive in a little bit behind what routing is, why we need it, and I'll be talking about React Router, which is a JavaScript library that makes this easier for us. So first off, what is routing? Routing essentially means that we can have different pages show up to the user depending on what that user's typed into the address bar. So a simple example here, let's say we're on YouTube. If you go just to youtube.com, to the homepage, then you get a layout that looks something like this. We have videos and they're sort of in this grid layout. Maybe there's like a recommended for you one, maybe there's some topic that you're interested in that gets sort of automatically rendered underneath. So maybe these blocks are sort of organized in some way. But then if we go to subscriptions on the left, the address bar will change to youtube.com/feed/subscriptions. And there's a whole different bunch of components that get rendered if we're at that route instead of a home route. And then similarly, if we go to trending, then there's this whole different layout again. So we need to give some way of our application to be able to handle this. If we put something in the address bar, it goes to one component. If we put something else, it goes to another one. And one really easy way of managing this, a super popular library, is called React Router. Actually, we tend to use React Router DOM. React Router is the, I think, sort of React Native version. We always need to use React-Router-DOM is the name of the library in NPM. And as you can see, 4 million downloads a week. It's super popular. To set up React Router, we need to install it using the command line. So in the project that we set up last week, for example, with Create React App, we can run the terminal command npm install together with the name of the package, which is react-router-dom. That will install the node modules that are related to this particular library. And then we get a bunch of stuff from that library that we can use to set up these routes. So one thing that we need to do before we can write any of these components in any of our files is we need to surround our entire application with something called browser router. So browser router, this is quite a common pattern in React, where if there's something from a library that needs access to the application somehow, if we need to be able to inject pieces of state, pieces of components, sort of track things around the application, we'll have some sort of provider tag surrounding our application. And then we can have these consumer tags that can then interact with the thing that's providing things. So this is all that this is doing here. Browser router just lets everything inside our app access the React router store, essentially. So that's getting set up. As long as we have that, we can proceed to write some actual React router code. And basically, we have two methods that we can use to create new routes. We have the switch component, which we get from React Router DOM, and we have the route component, which also comes from the same library. And the deal here is that it's a lot like a switch statement in JavaScript. So, so you can have these switch statements where, depending on the value of the variable that we put in different cases, we'll do different things. And in the exact same way with React Router, we have a switch statement, and each one of these routes you can think of as different cases So in different conditions of what's in the URL, we'll render different components. So the way to read this is that if the path is just a slash, so essentially just the home route of our application, then we're going to render the home component. If instead we get the path of /about, so this could be, you know, myapp.com/about, then in that case, we'll render the about component. And then if the address bar says /dashboard, so myapp.com/dashboard, we're going to show the dashboard component. So this one component that we're using here, that we created, called my component, depending on what's in the URL, we'll get something different each time. So hopefully that makes sense. Another thing to note with React Router is that we can also link between different pages using the link component from React Router DOM. So the way that this works is that we just need to put in the route that we want to link to in the to field. And this essentially creates just like a regular link that if you click on it, it'll take you to the same site. Again, all of these routes are relative routes. So we're not using an address like www.myapp.com/about. These are relative to the home route in this case. And one other thing to note here is that we had to use the word exact for the first route here. The reason behind that is that if we don't have the word exact, basically this switch statement will render all of the routes that match the path. So if we didn't have the word exact here and we were at the about page, so myapp.com/about, then this would also match the slash, because the router just looks at the URL and says, okay, if there's a slash at the front of it, I'm going to render that component. So if we had these two together without the word exact, then we would essentially render home and about for the about page, and home and dashboard for the dashboard page. So I think that it's kind of an easy mistake to realize that you made once you've made it based on the errors. But that's a really common thing to forget about. So just be aware that you need to use the word exact when there's going to be something following the URL that you're defining. So in this case, it's /about and /dashboard. This also works if you have nested routes. So if you had one of these switch statements inside one of these routes, you'd need to use the word exact for this route here, because otherwise you would render dashboard and dashboard/home or dashboard/123, for example. So just something to be aware of, but as I said, easy to correct when you realize what's going on. So we have this link component that we can use to link between different pages, but we also have something called use history that we get from React Router DOM. This should make more sense towards the end of this lecture, because use history is what's called a hook, which I think we're talking about in a few slides' time. But essentially, you can create this constant called history by calling this function called use history. And it comes from the exact same library again. So all of this stuff comes from React Router DOM. And with this history value, you can use the push method to add a new route onto the history of pages that you've been on, essentially. So history essentially is an array which has all of the routes that you've visited. And using the history.push method, we're essentially saying, okay, add this new route onto the history of routes that we've been on. So this essentially redirects us to whichever page we put into these parentheses. So this is essentially the same thing that's happening here as in this screen, except here we're programmatically redirecting using JavaScript rather than using this link tag that we get from React Router DOM. Okay, so that's React Router. That's navigating between different pages, showing different components depending on the page. Next, I want to talk about something called hooks. Hooks were a really recent addition to React. They only came out in 2018, late 2018, I think. And it's a really nice little shortcut that makes our lives as developers quite a lot easier. Essentially, they allow functional components to become class components. So once you know how to use hooks, you'll actually never really need to use class-based components anymore. You might see some class-based components code online, so it's always good to know roughly what these class-based components are doing. But in my day-to-day job as a front-end developer, I almost never write class components anymore. I almost entirely write functional components using hooks to hook into these this class component functionality. So yeah, I think this will become clearer and clearer as we go through some examples here. So hooks, they're essentially functions that we get that do some sort of functionality for us and give us some kinds of results. So the first hook that I want to talk about is something called USESTATE. And we get this from the React library. If you haven't seen this syntax before, we're importing React, which is the default export from the library of React, but we're also destructuring off of React something called USESTATE here. We could also have written this as react.USESTATE, because USESTATE is just a method on the React library. But here it's a little bit cleaner to destructure it like this. Okay, so the usage, the way that USESTATE works is that calling USESTATE with some initial value will give us back a 2-item array. The first item in the array is a piece of state that we can put something into. And the second item is a function that we can use to set that state. And we could have called these variables pretty much anything. What we're doing here is just using the ES6 syntax to destructure these values from the array that we get back. So we're calling this count, but we could also call it number. We could call it dinosaur, anything we can call this as long as it's descriptive and useful. And as I said, the argument is the initial value of that piece of state. So what this does is it gives us this variable called count. It sets it to 0, and it also gives us this updater, which can update that value to something else. So let's see how this looks. On the left, we're doing something with this hook called USESTATE. And on the right, we're doing the same thing using a traditional class-based component. So based on the syntax that I took you all through last lecture, if we want to use some piece of state, let's say we have a counter in this example, we need to first declare this state object with the piece of state that we want to track. So here we're saying, okay, state equals, and then an object, and we have this piece of state called count, starts up at 0. Inside of our render method here, we're using this onClick event to call setCount, which then calls setState using, this actually shouldn't, yeah, this actually doesn't work properly. Yeah, this functionality here works. I just haven't copied this over correctly. Okay, so we want to pass in, okay, this dot set state, passing in count equal to count plus 1. And then up here, we have to use this.setState. We can't directly mutate the value of state. We always have to use this.setState function to update the value of the state. So we're passing in an object. We're using ES6 syntax here to say, okay, I want to set the value of count to whatever we pass in as this argument called count. So this whole thing becomes quite messy quite quickly. It turns out that we can do the exact same thing using the syntax on the left. So we're declaring this variable called count, starts off at 0, same thing. And we can use this value of count inside of our render method for a functional component. This is just a variable that we're injecting in with curly brace syntax as usual. And we can just call setCount, the function that we get for setting the value of that piece of state. And it's just really simple function. It just takes one argument, which is the new value that we want to give it. So in this example, we have a counter. We're saying every time the button gets clicked, then we're setting the count with the current value of the counter plus 1. So this automatically updates, showing us the most recent addition of how many times the button has been clicked. Okay, so that's the useState hook. We can replace the need to have state in our class components by using this feature for functional components that is a lot cleaner and a lot easier in the long run. Okay, the next thing I want to talk about is the useEffect hook. UseEffect essentially allows us to replace the lifecycle methods in class-based components. So these lifecycle methods are like the component did mount method, the component will update method, the component will unmount method. All of these methods that we sort of get given for free from React that define behavior at different stages of the component's life. We can replace all of those with something called useEffect. So the deal with useEffect is that it takes a function as the first argument. We have to give it a function. And that function will run whenever the component renders, in the case of just having this argument like it is. So the first time the element renders will run useEffect. And then any time that something changes so that the component gets re-rendered, will also run this useEffect function. So that happens the first time and then on every re-render with nothing inside of it. But then we can give it a second argument as well. And if there's a second argument, then this useEffect function will run the first time, so it always runs the first time. And then any time that something in this dependency array changes. So it's not re-rendering every time, it's not running every time the component re-renders. It's just running every time one of these variables change. So in this case, we're only going to be updating the page's title if the count variable changes. We're not going to do that if let's say that there's a form inside of the component and somebody's typing their name into it, and every time that's updating the state, for example, usually that would trigger this useEffect function every time. But instead, we're just saying, okay, I only care about the count changing. Whenever that count changes, I want to update the title in this case. So this is also an example of using the component did mount method together with the component did update method. So before we had this method called component did update, and it's every time that the component re-renders, we run component did update. So that's a class method, class-based component lifecycle method. So this will always run the first time it renders. So that's kind of a replacement for component did mount. And if we use the dependency array, that's also kind of a replacement for component did update. One thing to note, which is something that's quite common, is if we have an empty array for the second argument, so the dependency array is empty, then it essentially just replaces the component did mount method exactly. So if we have some code like this, then this code should only run the first time that the element gets put on the screen. So this is really useful for something like data fetching. We want to fetch some data from the API. So we're using this fetch syntax again, passing in just the name of a dummy API here that gives us back some data. This is going to run the first time the app shows up on the screen, but every time after that, when some of the props change, when the state changes, when that component re-renders, we get nothing. So that's great for grabbing data the first time the component loads. And again, we can see this comparison side by side here. So we have this count variable that we're using USESTATE to track. And we're just doing this exact same example. So we can actually set title of a page through JavaScript using the document object. There's a property called title that we can set to put anything in the title of the page. And yeah, we have the same button, the same counter again. So again, we need to use state if we're doing this in a class-based component. And every time the count variable changes, in this case, whenever there's a re-render, we're calling this document title property and setting it with a new value. So these two are broadly equivalent. Hopefully you can see it's a little bit shorter. Maybe not right now, it seems that much simpler because it's still new. But it really makes our lives a lot easier when we only really need to worry about functional components. Up until now, I've kind of been saying that if we need to hook into the features of a class-based component, so if we're writing an element, running component in React, and suddenly we decide, okay, it'd be great if we had this piece of state. Before we would need to completely change that code to a class-based component. So we need to go through that 5-minute exercise of needing to remember how the syntax looks, needing to replace this return inside of this render method. And it was just kind of a headache thinking about, okay, should this be a class-based component or a functional component? So with hooks, we sort of take that whole decision completely off our hands. So it makes it a lot easier just having to worry about functional components, essentially. Yeah, so I would strongly recommend just getting really good at hooks, practicing this a lot, and only needing to worry about functional components rather than class-based components. Okay, so there are a few rules that we need to bear in mind for hooks. Simple rules that just based on how they were made, we need to follow these rules of hooks at all times. And if we try to break these rules, React will suddenly break the application. So you'll pretty quickly realize that something went wrong if something does go wrong, and it will tell you with a helpful error message what happened. So the first rule is to only call hooks at the top level of the component. So you can only write hooks like the first thing that we see inside of the component. We can't have another little helpful function in between, because React will always track which declaration comes first. So to make sure that hooks work, we always have to put the hooks before any other code. On that note as well, we can't put hooks inside of loops, conditions, or other functions. So they always have to be sort of the top level of hierarchy as well as the top level of the component, the top level of scope. So we can't nest them inside of something else. And we can only call hooks from inside function components. We can't add a hook into just a regular JavaScript function. Hooks are only meant for functional components that we want to add to our React application. So this first rule, again, I just have an example here of something that's really common. We might want to say, okay, we have this function called getUserInfo. Maybe this makes a request to the backend and grabs some data about the user, for example, and populates that into our app. Really common thing that we might want to do. We might want to say, okay, I want to use this conditional. So I want to say, okay, if the user is logged in, then I want to call this effect. So on the one hand, let's say that the user is viewing the page as a guest. Then we shouldn't be making this expensive call to the backend to grab that guest data and have to do something with it. I only want to do that if the user's logged in. So we might say, okay, I want to do something like this. I want to put a conditional around it and say only run this use effect code if the user is actually logged in. This will just break the application. It breaks the rules of hooks, that the hooks always have to be at the top level of scope. We can't hide hooks away nested inside something else. So with this really common use case, the way to do it is like this. So we're using use effect at the kind of the top level. So this will run, in this case, the first time, and then also every time is logged in changes. So if the user suddenly flips from being not logged in to logged in, we'll also run this function. And again, we're just saying, okay, if the user is logged in, then make this request. So that's totally okay. Just as long as use effect is always on the outside, always at the top level, then React won't yell at you and there'll be no problems. Okay, next thing I want to talk about is Material UI. Material UI is an awesome library that gives us lots of really great React functionality totally outside of the box. So we covered Bootstrap a little bit back in week 1, which is pretty similar, except Material UI is way more advanced and also way more modern. So pretty much every sort of professional project I've been doing as a front-end developer in the past like 2-3 years or so, I've always been using Material UI just to make 80% of the product essentially. Material UI comes with lots of default components that are sort of engineered to look nice automatically. And you essentially get this massive component library to play with. So Material UI is a library. So again, you can get this using NPM. There's an NPM page where there's some documentation. There's also a documentation page that explains all the components. To install Material UI, again, we can just use NPM. So we can run npm install. The name of the package starts with an @ which is kind of annoying. There's a different package called Material UI that doesn't start with an @ and it's no use at all. So always remember to just copy and paste what we find from npm @Material UI. So the core library, like all the components, live at the Material UI /core library. And there's another library called the Material UI icons library, which gives us some like nice looking icons that we can put on our app as well, totally for free, totally outside the box. And in terms of using these components, it really is as simple as importing them from the core library and just writing them like any other component that we made ourselves. There's a list of props that you can optionally put onto these components, and you can just look those up in the documentation page. There's really nicely written documentation for every component that shows us how we render them, what kind of props they're expecting, for example. And in the case of the button, we can just use this button component, and whatever we put inside of it will be the text of the button. And this button just looks awesome, totally out of the box. So yeah, so most of the work that I do as a web developer is just entirely using the Material UI library, using little tweaks here and there to make it fit the color scheme or whatever. But we're essentially just putting together lots of building blocks that we get from the Material UI library. As a slight tangent here, material design was a design philosophy created by Google. So all of these components, the deal with material design is that it's supposed to look like pieces of construction paper. So you imagine you have like one massive sheet of paper and you're putting different pieces of cardboard on the paper. So all of the pieces of card have like an elevation. And all of the specifics on how all of these components should be rendered on the screen were all decided using like a really rigorous scientific process of what's most intuitive to users. So as long as you use the rough components that Material UI gives you, using the sort of rules of thumb that Google also give you using material design, then your page will automatically look like a really professional, well-made application. So you don't need to do too much sort of low-level editing of things, changing CSS to make everything look great. If we do want to add some customization onto these components, I showed you something similar that I did last lecture, just having a constant called styles, which was an object of all of the different CSS properties that we wanted to set. We get this hook called make styles from the Material UI core library. And using this make styles hook, we can pass in a particular CSS declaration we want to apply. And then we have to use this thing called, we have to call this function. So calling make styles returns a hook. And when we call that hook, this gives us a giant object called classes. And we just need to set the class name to whatever gets generated here. And that will automatically apply all of these styles to that component. So that seems like kind of a really roundabout way of doing things. The way that this works is that this class name will always equate to some sort of really long string that means something to Material UI, but doesn't really mean anything to us. And then Material UI in the background will create a style sheet from this information and match up the sort of randomly generated name with this particular style declaration. So this is just a little bit of a pattern to get into. This is like a really basic functional component sort of building block that we use for pretty much every component. So after a while, you'll sort of get used to this and figure out all of these steps. It's totally okay to look up any of the syntax the first time you do it. And I was definitely doing that for the first 3 or 4 years that I was using React, so no pressure. And as I said, Material UI documentation is awesome. It comes with concrete examples of all of the components, and it gives you the actual code to create those components. So in this example here, you can see how beautiful these buttons look, and it's just a case of calling these components. It really is awesome just how much stuff we get totally for free from Material UI. You also get lots of sort of default behavior if you sort of click on them. There's a nice ripple effect. You can have these kind of disabled look of a button. If you want to disable a button for some reason, you just need to pass in the proper disabled, for instance. So yeah, so for the bonus homework this week, you can get a chance to actually use the Material UI documentation in a real app. There's a Mad Libs app this week, which is super fun, I think. And if you get around to that, then yeah, hopefully you can get a feel for just how much power it gives you to be making these apps using a component library like Material UI. Okay, last thing I want to talk about today is application level state. So we've talked about component level state before, where we can say, okay, this button, it wants to track how many times a user's clicked on it. There's a variable that button can access called count, and we can update that button count whenever we click on the button. In React, we can make all of our components like this and pass state between props, but this quite quickly becomes difficult in large applications. So I'm going to talk about this concept of app level state, talk about why we need it, and I'll introduce you to something called the React Context API, which is a really nice way of solving this problem. Okay, so There's this concept in React called downward data flow, which means that we can only pass props from a parent to a child. So we have an example here. We have this component called parent, and we have this component called child. The parent has a piece of state called child name. We're using this USESTATE hook to generate this variable called child name. And we also get this the state setter called setChildName. So at the moment it's called Gary. And we can pass the name Gary from the parent to the child. So it's sort of like this downward direction of data flow from the parent, from the highest level of hierarchy to the lowest level of hierarchy. But we can't do the opposite as easily. So if instead we had some variable that we defined in the child components, then it becomes really difficult to be able to pass any changes up to the parent. The nice thing when going from parent to child is that whenever something changes in the parent, so if we update the name of the child, for example, then automatically that change gets reflected in the child. Because every time one of the props changes, every time something inside of this return statement changes, we automatically re-render that component, and then by association, we're then re-rendering the child. So that's a nice thing that we get automatically with React, but it doesn't work in the opposite direction. So if this name is just defined inside of this child component, we change the name, that's not gonna match the value that we have in the parent as well. So to fix this, the really common design pattern that we tend to use is called lifting state. So with lifting state, we're still passing the name of the child down from the parent to child, but we're also passing the function to set that piece of state down to the child. And then in the child, if we want to trigger the change of the piece of state, then we also need to call the function to change that piece of state. So in this example here, we're saying, okay, we want to create the name inside of the child component. And every time that name changes, then this child component gets updated, but the parent doesn't get updated. So to update the parent as well, we're passing in this function called onChangeName, which is then going to change the name of the parent. So if this sounds really convoluted and complex, it is. So this quickly becomes a problem if we have lots of components that we need to do this for in our application. If we absolutely have to set the name of the child at the child level, it becomes a lot easier if we can stick to this downward data flow model. But in larger projects, that quickly becomes quite difficult to do. So that's just with one parent and one child. You could imagine when there's a sort of grandparent, parent, and child, there's three components that render each other in order. In that case, so we want the name of the child to come from the child component, which makes sense. We want to be able to set that child's name using this setName function. So if we change the child's name in the child component, then that gets re-rendered. But then we also need to reflect that up to the parent and then to the grandparent. So in the grandparent component, we have this function called update grandchild name. We need to pass that down as a prop to the parent. And then we also need to pass that down as a prop from the parent to the child. But then we also need to add the update child name method, which is going to change the parent's child. So at this point, it just becomes like way too complicated. So we have all of these state updates. We need to lift up the state from lots of interwoven components all around of our component tree. So it just becomes way too complicated. So in a production level application, most applications that are out there today that are sort of big enough to need state management, we have some application level state, which is basically like a giant object that any component can directly access. So instead of carrying this child's name at component level, we could instead just put it in this big store or application level state. And we can just then tap into that store directly from any of these components. And then we can also update that store from any of these components. So in this case, okay, we have this child's name called Gary. Let's say inside of the child component, that child says, okay, I'm gonna be my own person. Suddenly I'm not gonna be called Gary anymore. I wanna call my name Andy. Then the way that this works is we can use a set name function from the store that will change the value of the child's name to Andy. And then because we're tapping into that store for each of our components, we'll automatically re-render the grandparent, parent, and child. So this sort of whole paradigm just makes everything so much easier for defining components that need to interact with some state at all levels of the hierarchy. So in React, there are a couple of really common stores that people tend to use. There's a library called Redux, which is probably the most common solution to this problem. Redux is super complicated. I'm going to mention this in the last lecture of this course. To make Redux work, you basically need to make like 5 different files every time you want to add a new piece of the store. But it's really scalable. So you can use Redux for a massive application. There's some really nice inbuilt design principles that make it quite easy, or at least difficult to make big mistakes with. But there's lots of things to learn with Redux. There's also a store called Mobex, which is a little bit more simple. It's just like, okay, here's this object and I want to tap into it and set things on it. That's a little bit easier. What's even easier is something called the Context API, which I've been using more and more for actual work projects recently. They added this back in 2019, so fairly recently. And it comes with a React library by default. And it allows us to tap into application level state and store things globally that we can access from all components. So to do this, there are a few different pieces that we need to be aware of. So to set context up for the first time, we need to use a provider. So again, this is similar to this browser router that we're using for React Router. We need to wrap our entire application in this component. And that means that the component knows it can store some state on that parent component and then just inject that component to any level of hierarchy inside of the app component. So setting up the code like this, using the provider that we're exporting from the context that we define, we can pass in a value, which is the application level state. And then anywhere within any of the components that we have inside of our folder hierarchy, we can then use this consumer component that we also get from our name context file. And if we write things like this, then we have access to something called context, which is basically the object that we're storing things on. So I'm a little bit less certain about this because I never actually write things this way. The easier way to do things is like this. So we have some provider. We can export this from the name context file. We still need to wrap it around our application. But we now have something called the useContext hook, which comes from React. And if we pass in a context, then we get back an object which is all of the things that we're exporting from that context. So that's a lot easier not having to sort of wrap things in a consumer. So in terms of what this context looks like, here's the code that we're using to actually set this context API up. So you can see we're using these contexts in this file and this file. We're importing this thing from this file called namecontext.js. And in terms of what that looks like, we have a file. We can usually declare this in its own folder. Usually we'd have a folder called contexts. And we can have a file called namecontext by default. And the deal is we can use this thing called react.createContext. And we just need to pass in the sort of initial value of the state as the only argument. And then inside of this provider here, what we're doing essentially is we're using USESTATE inside of this component. So this provider component is the exact same component that we're using to wrap our application in. It all comes from this thing called nameContext, which we're exporting from this file. And so by default, these namecontexts, when we create them, so all of these name contexts, all these contexts that we get from create context, there's basically an object that contains two different React components. There's the provider and there's the consumer. So here what we're doing is we're creating a new component called provider. And all we're doing is wrapping whatever we pass in. So we're wrapping whatever's inside of this provider when we actually use it. So we get access to that using something called children, which I don't think I mentioned yet. So this spits out everything that we plug inside of the component as a nested component. So that's the children. And we just have this piece of state, in this case called name. And we're passing both the name and the change name function, the set name function, in as the value to the store. Okay, so that was a really long-winded explanation of context. This is what we end up with, which is quite elegant. As long as we have the application surrounded by this provider, and again, like whenever I set this up, I just look it up, like the implementation that looks exactly like this. So don't feel the need to memorize anything as usual. If you read through this yourself, use it in your own project, eventually this makes sense of why it's structured like this. And okay, yes. Yeah, and then from any component, we can just use the exact same use context hook that we get from React. And as long as we pass in the context that we actually want to use, so the thing that we got from react.createContext and that we're exporting, then this will automatically let us use these variables inside of our components. So in this case, we're using both the value, the variable of name that we're storing on the application level state of the provider components. And we're also using the set name function or change name function. There's a slight spelling mistake there. Okay, so that's everything for this lecture. This week's homework, I wanted to add in some free code camp exercises like normal, but unfortunately there's nothing related to context hooks or React Router, which is quite frustrating. So instead there's some videos to watch, and I would really recommend checking out the bonus homework if you have some time this week. Even if you can't finish the whole thing, there's a really awesome exercise that you can check out where we create an entire application where you have like a Mad Libs generator. So you can create a funny story from using forms to input different pieces of data. Okay, so that's everything for this week. As usual, the homework is due by next Tuesday. If you just do the regular homework, it will be a lot quicker, a lot simpler than usual. So best of luck for that, and I'll see you next week.